Today we're going to talk about asynchronous Zig with LibXEV. So let's pull that up. Okay, I'm going to make this bigger so it's legible for you all. Okay, cool. So there's a couple different ways to do async in Zig at this point in time. At the time that this video has come out, Andrew Kelly has also mentioned that async is back on the table for Zig. I don't want to be incorrect on this, but either 0.15 or 0.16 probably. It's in the 2026 roadmap. So yeah, Async Zig is back on the table. But in the meantime, I'm going to show you how to set up an event loop with LibXEV, which I have been noodling around with for a little bit. So I've got a really simple example here today. I've kind of distilled things down to the bare minimum to really illustrate a point. But one of the things I do want to talk about is that it supports abstractions for non-blocking I/O, timers, events, and more. Works on Linux, macOS, and Wasm and WASI. Also available as a C API, which is cool too. And the part that we're going to focus on today is timers, because you can do basically everything else with timers. But there are also ways to approach non-blocking I/O and events and things of that nature, which might be interesting as well. So there's some information about it here. Why a new event loop library? Zig lacks a generalized event loop. True. Comparable to libuv in features, generalized being the keyword here. Yep, sure, that makes sense. Build a library around the design patterns of I/O uring. Some of the information about features and all of that fun stuff. You can read through this. I don't need to go through it on stream for you. Actually, some really nice examples here as well. We'll follow this pattern quite a bit. So there's information on installation and all of that fun stuff. This mentions Zig 0.11. I can confirm it works with 0.14. So yeah, let's do that. So I've got a project up here. It's brand new. I just ran Zig init, and I'm going to do a Zig fetch. And the number that is right here is the commit hash in GitHub. So we're fetching just the tar gz. It's being added right here, which is great. We need to add that dependency to our build.zig. So let's go ahead and do that. Oops. Build.zig. Yeah, let's just throw it in right here. So const xev is b.dependency, and the name is libxev. Any args we want to pass to it. So like target is target, and optimize is optimize. Give that a semicolon. Okay, we're going to come down here to exe mod. We already have an import path here for the lib mod. So what we're just going to do is add another one for xev right here. And that's going to point to xev.module and then xev. I think that should take care of it. So let's give this a Zig build run and just make sure that everything builds properly. It does not. Let's take a look at our build.zig.zon. What do we have down here in our dependencies? Oh, interesting. It wasn't added. Okay, I added --save at the end. Totally forgot to do that. Just ran cat just to make sure that it is showing up here in our dependencies, and it is, and it's libxev. So I think we should be good to actually run Zig build run, and hopefully it compiles this time. And again, we haven't actually implemented any of the libxev stuff yet, so we're just making sure that our dependencies are wired up, which they appear to be. Okay, so with that in mind, what we're going to do is I'm just going to fire up main.zig here in Vim. I'm going to go ahead and delete everything. And I'm going to go ahead and pull in the standard library, which is going to be import std, pull in xev. That's going to be import, and we called that xev, so we just import xev like that. All right, and once we have those two right here, we can go ahead and start working on the actual LibXEV implementation. So we have two different things that we really want to do here for this example. We're going to set up a timer, and that timer is either going to rearm itself or it's going to disarm itself. So it'll be a recurring timer, or it'll be a timer that does something and then stops. So if you're familiar with JavaScript, you can think of these kind of like set interval and set timeout. I think respectively. I think I've said that in the correct order. Set interval would be the rearming timers. Set timeout would be the disarming timers. So with that, we need some timer data. So what we're going to do is we're going to create a struct called timer data. Why not? And this struct is going to have maybe a message. And this will be const u8. Maybe an ID might be useful as well. And then a strategy. And this is going to be xev.callbackaction. So callback action is an interesting type. What it is either it's an enum that points to either disarm or rearm. So in the case of our timer, it needs to return either disarm or rearm, and that defines the behavior. So what we can do is we can use the same timer callback each time and then just look at the strategy to determine whether we should requeue or not requeue. The second thing we want to do is essentially I want to have like a poison pill message that comes in and just stops the entire thing. So we're going to create one called stop data, and this is going to be another struct as well. I actually don't know what we need for this one yet, so we'll leave that empty, and it might just stay that way. Let's go ahead and set up our callbacks. So we have a timer callback, and if we look at the docs for libxev, if I can pull that up, you can see that there's somewhere a timer callback that looks like this. So here's an example. This one returns disarm. So what this callback does is essentially it gets user data, the loop, the completion, and the result here, and then disarms the timer. That's it. So what we can do is essentially the same thing. So what we're going to do is set up a timer callback. We do want our user data. We need that because that's going to be our timer data. And then we actually don't care for the loop. We don't care for the xev.completion. And we don't particularly care for the xev.timer run error unioned with void. Okay. You might care for these things. And if you do, don't use underscore. Bind them to a variable. But in my case, for what we're building right here, we don't actually need those values. XEV callback action is the return type, as we just mentioned a few moments ago. And I'm just going to do something like if user data, let's bind that to data. Good, it's timer data. LSP is not given up on me yet. Standard debug print. I just want to print timer d s \n maybe. And then we can do something like data dot ID and data dot message. That should take care of it. We do need to return a callback action here, right? So one of the things that we did is we have a strategy on our user data. So if we do have user data, let's go ahead and return the strategy from it. Return user data dot strategy. Oh, sorry, return data dot strategy. There we go. But we do need to return in the case that we don't have user data, and we'll consider that to be an invalid state. So we just want to disarm the timer. We don't want to rearm the timer if we're not actually getting user data, because that's not what we want to do. Okay, we're going to have one more. I'm going to go ahead and just yank all of this right quick. And we'll come down here, paste it, and then I'm going to change this from timer callback to stop callback. What's interesting here is we actually are going to change this up a little bit more. We maybe don't need stop data. Maybe we do need stop data. I'm going to go ahead and empty that one out. We do need the loop because we want to stop the loop. And I don't think we need completion. I don't think we need result. So we'll leave those as it is. So all we really want to do here is, since this is our poison pill, we are going to call loop.stop. and then we'll return disarm. So now that we have these callbacks up, we actually need to use them, right? So let's go ahead and wire up a main method. So pub fun main, error void for the return type, debug allocator, standard heap, debug allocator. Finally at the point where I'm not muscle memorying GPA, which is great. And then defer debug allocator.dinit. Okay, so now that we have an allocator, let's set up our loop. So I'm going to say var loop is equal to try xev.loop.init, and we can provide it some options. I actually don't know what these options are, so let's see the options doc for what options matter for IOCP. So we could take a look at that and see options. I don't see them here. I'm sure that information is in here somewhere. So far, I haven't actually needed to see FAQ Zig. Information on adding a completion. Yeah, I guess that's actually a really good point too. I mentioned earlier that timers that don't rearm themselves are essentially like set timeouts. That's technically not true. So a completion would be a set timeout from like the JavaScript world. However, if you have a timer and it doesn't rearm itself, maybe that would be more akin to a set interval that clears its own interval. One of the nice things about that is you could programmatically decide if a timer needs to requeue or if it needs to disarm itself, or I should say rearm or disarm itself. So there's some flexibility in there that would be difficult to get in the JavaScript world, or at least approaching the problem the same way. Some information on running the loop. I don't see anything on those options, so we're just going to pass in an empty struct, right, like that. And now that we've initialized our loop, we want to defer loop.dinit because we like to clean up after ourselves. And then I'm just going to do a standard debug print, something like starting libxev async example ... Maybe a little backslash right there and some args. We don't really have any, so we'll just pass in an empty struct. Okay, this should start. This should work. This should be good. But we're not actually doing anything yet. So we need to wire up these timers. So I'm going to set a const timer. I'm just going to call it timer1. And I'm going to say try xev.timer.init. Defer timer1.dinit. Okay. And we'll set up our timer data. So var timer data, message, and then that message is going to be something like timer1 fired, just something to indicate that that timer is the one that has fired. We do pass in an ID, so I'm just going to set this one to 1 since it is timer1. And then the strategy is going to be rearm. So this timer will continue to rearm itself as it continues to go. And again, if you wanted to programmatically decide on that, maybe you wouldn't decide whether it should rearm or disarm in the struct, but instead you would, in your callback, you would, do whatever job you're doing and then decide whether you need to requeue it. So for example, maybe you have an event loop in a game and it needs to keep going unless the game is tearing down, in which case you might disarm all the timers after they complete. That way the timers would complete successfully and then you don't get the game in a weird state while you're shutting it down. Okay, so we have our timer data. This looks good. We need to give this a completion, right? So what we can do is create a new completion. I'm just going to call it C1. I'm going to give it a type of xev.completion and then set that to undefined. And then we can do timer1.run. So we want to run this timer against our loop. And then I called this V1 instead of C1. Let's make that more clear. And then the second item that we need to pass in is our completion. So at C1, when do we want to run this by? 3000 milliseconds. Our user data type is going to be timer data. It looks like my LSP is struggling a little bit here. And then we want to pass in that instance of timer data, and then the callback that we want to run. So in our case, we want to run the timer callback. Okay, weird. It seemed to have sorted itself out, which is great. Okay, so that should run our first timer. So what I'm going to do is, click over to this other tab over here, and then just do a Zig build run. Looks like we have an error on 14. I think this is just a capitalization issue. It is a capitalization issue. Okay, let's give this another run. Zig build run. Starting LibXEV async example. So this finished before it actually executed our callback, which is maybe not what we want. In fact, I can tell you for certain it's not what we want. So what are we missing, right? Well, we want to tell our loop to actually run, and it needs to wait. So I want to try loop.run, and then the mode is going to be until done. So I want to run this until all of the items are done. And then at the end here, what we're going to do is do a standard debug print event loop finished. Something to let us know that we are done. Let's give this a run. Okay, it's starting. And I think, so it's queuing up immediately. We will come back and fix that in just a moment, but I want to go ahead and show you two more things before we start debugging. So we're going to do the same thing here with another timer. So I'm actually just going to go up here and grab all of this, and we'll put some space down here and paste right here. So instead of timer 1, this will be timer 2. We'll come down here and change this to timer2.dinit. Timer data is no longer the name that we can use, so we're just going to call it timer data 2. This completion is C2, so we'll change this to C2, and then we need to pass in timer data 2. And the main thing that I want to show you here is that if we pass in 2 and we set this to disarm, it won't requeue. Another interesting piece here is we are defining this timer after our first timer, but if we set a lower millisecond interval, then it will run first. Let's see, so timer 2.run. And if we do that, it'll run. It'll be flooded out by all of these timer 1 messages that are rearming. So I'm just going to flip this to disarm just so we can see the two messages. Let's give this a Zig build run, and we should see timer 2 kick off first, and then timer 1 kick off, and then it finishes. It does still say timer 1, even for timer 2, and the reason why is because I did not update this ID. So we'll update that ID, give it another run just to make sure that nothing else seems off. We should see timer 2, and then timer 1. Perfect. And I'm just going to clean this message up just for cleanliness. Okay, so what about that poison pill, right? So we talked about that. Maybe we want to kill off the loop, and maybe we want to do that based off of a timer or some other completion. So what we can do is, for simplicity's sake, I think I am just going to grab these, paste these here, change this to C3 since it's going to be our third completion. And then we do need another timer as well. So I'm going to yank this, come down here, provide some space, change this to timer 3. Timer 3. I don't think we need any of that, so we do need the completion though. Change this to timer 3 as well. The type, we called this stop data. And then for the struct, we can pass in something like that. Maybe stop data like so. We have an unused local variable, so we need to queue up that completion here like so. And now if we do this just right, what we'll have is we'll see timer 2 finishes, and then the poison pill comes in and kills the loop before timer 1 has a chance to complete. Oops. Okay. This needs to be a reference. Let's give that another go. Oh, it's can't be const. Interesting. Wait, it can be... Yeah, okay. It can be nullable, so let's just make it nullable. Pointer type main stop data cannot be cast to timer data. That's because our callback here needs to use the stop callback. Instead of the timer callback. Let's give this another go. Okay, it's starting. Timer 2 fires, and then the event loop finished. So that poison pill is going through. It might be hard to see. So what we're going to do is come back up here and then loop stop, do something like standard debug print poison pill acquired. Sounds ominous. Give this another run, and then you should be able to see that shake out right here. Yep, so you can see it started, timer 2, and then poison pill acquired. I forgot a line break, so then it says event loop finished on the same line. There's that line break. Okay, yes, I think this is pretty good. So the one last thing to look into is that rearming issue, and I may have misspoke earlier. And looking at the documentation a little bit for rearm, what I see is not what I realized. So if you disarm, the request is completed, not repeated. That one's correct. For example, a read callback only fires once and is no longer watched for reads. You can always free memory. You can always free memory associated with the completion prior to returning this. Cool. However, if you were to rearm, you requeue the same operation request with the same parameters with the event loop. That sounds like exactly what you would want. This makes it easy to repeat a read, timer, etc. Also seems really like what you would want. Rearms exactly as is. It's a little sketchy. What does that mean? Well, right here. For example, the low-level timer interface for IOU ring uses an absolute timeout, which means if you rearm the timer, it will fire immediately because the absolute timeout will be in the past. So rearming is maybe not the approach to take there. You could kick off another timer. There's a lot of options that you could approach here, but rearming, if you wanted to essentially set like an interval, is probably not the correct approach. Sorry about that, and sorry about the miscommunication. I am curious, since they specifically pointed to IOU rings absolute timeouts. I don't know much about epoll or kqueue, or what the Wasm or WASI implementation looks like. So I'm curious if that behavior is the same or if it's different on those other underlying systems. Those, again, being epoll, kqueue, or whatever the Wasm or WASI implementation is. Anyways, so outside of that one little blunder there, hopefully you found this video helpful and have a decent understanding on how you can use something like LibXEV to support asynchronous operations with an event loop in Zig. If you found this video helpful, let me know in the comments below. It brightens my day to hear from you. If you haven't yet, join the Discord server. I'll post a link to that in the description as well. And then subscribe to the channel. We're all friends here, and I'd love for you to be a friend as well. I think that's it, so thank you and have a great day.